China's latest 2025 megaprojects are so massive, they've left even global superpowers stunned. From entire cities rising at record speed to futuristic infrastructure that pushes engineering to its limits, these projects are rewriting what's possible. In this video, we're diving into the mind-blowing developments that have the entire world watching in disbelief. Few infrastructural feats have left engineers in the United States as stunned and envious as the towering ambition behind China's Huajiang Bridge, an upcoming marvel slated for completion in 2025. Designed to span the steep cliffs of the Huajiang Grand Canyon in Guizhou Province, this bridge reaches an audacious scale and level of difficulty that highlights the ever-widening gap in megaproject execution between China and the US. While American infrastructure debates continue to spiral in congressional gridlock and environmental reviews that can stretch over decades, China continues to design, approve, and construct record-breaking infrastructure with almost surgical efficiency and precision. The Huajiang Bridge is yet another symbol of that accelerating divergence. This bridge, when finished, will boast a main span exceeding 1,200 meters and soar over 600 meters above the canyon floor, making it one of the highest and longest suspension bridges ever attempted. The geology of the region posed formidable challenges. Vertical limestone walls, unpredictable rock formations, and narrow staging areas at the base of the cliffs all had to be accounted for. But Chinese engineers approached it with their now characteristic combination of advanced digital modeling, high-precision topographic scanning, and bold logistical choreography. Anchoring the bridge involved blasting into sheer canyon walls and installing massive foundation bolts hundreds of meters above the river, all while suspended from custom-designed climbing platforms. In the US, such a proposal would have likely been shelved due to cost overruns or public opposition. In China, it's simply business as usual. The twin towers of the suspension bridge, both of which exceed 300 meters in height, were constructed simultaneously using self-climbing formwork systems and high-strength rebar cages pre-assembled on the canyon rim. Materials had to be transported to the cliff edge using custom-built mountain roads and heavy-lift cableways, then hoisted downward or laterally as needed, a logistical nightmare in any other nation, but one that China's construction teams executed with startling smoothness. Even the installation of the main suspension cables was orchestrated with a degree of speed and scale that has left civil engineers worldwide in awe. Giant drone-assisted cable pulling systems were used to draw the initial pilot lines across the span, followed by layer upon layer of prefabricated cable bundles precisely tensioned to carry the deck's enormous load. By contrast, American infrastructure projects often face death by 1,000 cuts, delays from lawsuits, aging regulatory frameworks, and deeply fragmented oversight. The Huajiang Bridge, while operating under no less stringent safety or technical standards, benefits from centralized planning and vertically integrated construction firms capable of delivering entire megastructures from start to finish under one national mandate. The result is not only speed, but technical audacity that seems increasingly out of reach for the United States. Once open to traffic in 2025, the Huajiang Bridge will do more than connect mountain communities. It will stand as a monumental challenge to American engineering leadership, a reminder that while the US pioneered the megastructure in the 20th century, China is redefining what's possible in the 21st. If there's one project that has completely shaken the core of American hydroengineering circles, it's China's Yalong-Zangbo Medog hydropower project. Slated for completion in the late 2020s, this colossal undertaking is not just an energy generator, it's an audacious declaration of engineering dominance. The scale, complexity, and geopolitical audacity of damming the world's deepest canyon on the edge of the Tibetan Plateau is something the United States with its fractured permitting systems and endless litigation cycles, simply could not imagine executing. For China, it's another step in an aggressive infrastructural vision that no other country dares to match. What makes this project particularly mind-bending is its location. The Yarlung-Zangbo River, which later becomes the Brahmaputra, snakes through some of the most remote, geologically unstable, and topographically extreme terrain on the planet. The proposed site, near Medog County, is surrounded by seismic fault lines, landslide-prone cliffs, and a canyon deeper than even the Grand Canyon in Arizona. This is not a place where one simply builds anything. Yet China is building the world's largest hydropower station by output, in defiance of every conventional engineering restraint. While the United States still celebrates the Hoover Dam, an impressive project for its time, China is constructing something that will dwarf it in every conceivable metric: installed capacity, vertical drop, construction risk, and environmental scale. American hydro projects haven't crossed the 10,000 megawatt threshold in decades, while this Chinese project is projected to deliver nearly triple that amount. It's not just a question of ambition, it's about execution. In the US, environmental impact assessments alone could stall a similar venture for over 20 years. In China, environmental management is integrated into the design, but not used as a bureaucratic weapon to halt national progress. To tunnel through the Himalayan bedrock, Chinese engineers are deploying some of the world's largest tunnel boring machines ever built, capable of grinding through high-pressure metamorphic rock under extreme tectonic stress. These machines operate in tandem, digging multiple access shafts and flood diversion channels in parallel, supported by an army of geotechnical specialists monitoring every vibration and pressure fluctuation in real time. Concrete pouring is staged by altitude, requiring aerial logistics chains using heavy lift helicopters and drone-supported cable cars. Workforce camps and supply depots were built years in advance, anticipating weather patterns and monsoon cycles that would paralyze most other nations' efforts. The dam structure itself, still under assembly, is expected to be a multi-arch double curvature design, one that balances seismic resistance with the massive force of Himalayan meltwater. High-strength, roller-compacted concrete and hybrid fiber reinforcement technologies are being used, many of which haven't even been adopted at scale in the United States. American firms still struggle to retrofit bridges with seismic dampers. China is building an entire megastructure atop an active fault zone and making it earthquake resilient from the foundation up. When the Yarlung-Zangbo hydropower project goes online later this decade, it won't just be a symbol of energy independence or regional integration. It will be a direct engineering rebuttal to the stagnation of American infrastructure. China is taking on the hardest, most dangerous, and most technically challenging projects in the world, and finishing them. Meanwhile, the US continues to patch potholes and argue over environmental permitting for high-speed rail that may never arrive. The message could not be clearer. Sometimes a single structure can say more about a nation's priorities and capabilities than any policy speech or infrastructure bill. In the case of China's Chengdu Greenland Tower, scheduled for completion in 2026, the message it sends to the United States is deafening. We build faster, taller, and smarter. And we do it in cities most Americans still haven't heard of. While US skylines remain largely frozen in time, dominated by 20th century icons like the Willis Tower or the Empire State Building, China's second-tier cities are launching futuristic super-tall skyscrapers with the kind of complexity and ambition that the US construction sector hasn't touched in decades. The Chengdu Greenland Tower is not just a tall building, it's an ultra-modern engineering challenge wrapped in a sculptural form that responds to seismic threats, urban density, and environmental sustainability, all while reaching above 460 meters in height. Located in a high-risk earthquake zone in Sichuan province, The structure is being built with a tuned mass damper system and a composite megaframe core, incorporating cutting-edge materials like high-performance steel and triple-layered laminated glass. This is not ornamental architecture. It's a hyper-optimized vertical system engineered to stand firm through major seismic events while hosting thousands of workers and residents. American builders have not produced anything this complex in the last 2 decades. Efforts to construct super talls in US cities are routinely bogged down in zoning disputes, FAA height restrictions, or budget collapses. Meanwhile, Chengdu, once dismissed as a regional backwater, is executing a vertical city that blends high-rise office, residential, and hotel functions into a single integrated tower. And it is doing so with logistical precision and architectural finesse. Foundation works required deep pile caissons sunk through clay-heavy soil layers, stabilized by an intricate diaphragm wall system. The engineering firms behind the tower developed site-specific simulations to predict seismic behavior and tailored the structural core to shift torsion loads away from high occupancy areas. Elevator systems inside the Chengdu Greenland Tower will include some of the fastest double-deck lifts ever installed in China, traveling at speeds American skyscraper designers haven't dared to implement outside theoretical models. Vertical transportation planning has been handled with millisecond optimization, reducing wait times and energy usage through machine learning algorithms tied into the building management system. This is not just design, it's architecture embedded with computation and real-time control, something the US has only lightly experimented with in prototype buildings. China's capacity to realize this level of structural and systems integration in a city like Chengdu, not even one of its 3 largest metropolises, reveals just how far the engineering gap has grown. The Chengdu Greenland Tower, once it opens in 2026, will stand as a vertical demonstration of China's lead in megastructure execution. While the US continues to debate climate adaptation, seismic safety, and urban densification, China is putting all 3 into practice, stacked floor by floor into the clouds. It's a stark and undeniable contrast. One nation is constructing the future skyline, while the other is still managing the legacy of a past era. In the rapidly evolving world of electric vehicle manufacturing, nothing has jolted the American industrial sector more than China's audacious BYD megafactory rising in Chengdu. This massive complex, scheduled for completion in 2026, is not just a car plant. It is an entire city of automation, logistics, robotics, and scale that utterly eclipses anything under development in the United States. Even in Detroit or Fremont, there is no comparable project on the books, let alone in progress. China is building what amounts to a self-contained EV ecosystem, while the US continues to retrofit aging plants and squabble over battery supply chains. The factory footprint itself is staggering, covering several square kilometers of meticulously planned production, testing, and research areas. It is designed not only to produce over 1 million electric vehicles per year, but to do so with a level of vertical integration that American manufacturers have largely abandoned. Everything from raw material intake to battery cell assembly, body stamping, painting, motor construction, and final vehicle assembly is being consolidated into a streamlined flow that minimizes logistics redundancy. Unlike the US model, which often relies on scattered Tier 1 and Tier 2 suppliers across state lines or even continents, BYD is building an end-to-end supply chain within a single fortified industrial perimeter. The United States is watching with a mix of awe and resignation. The speed with which the Zhengzhou megafactory has gone from approval to foundation work and into structural assembly is nearly inconceivable in North America. In the US, a similar facility would be mired in environmental hearings, zoning disputes, utility negotiations, and political grandstanding. BYD, on the other hand, coordinated regional infrastructure upgrades, roads, rail links, and power grid expansions in parallel with factory construction, avoiding the inefficiencies that plague even the most well-funded US auto projects. Inside the complex, the engineering choices lean heavily toward modularity and future-proofing. High-capacity clean rooms for battery production are being installed with robotic atmospheric sealing and nitrogen supply loops, features that US factories still consider cutting edge. The stamping presses, sourced domestically in China, are capable of near-continuous operation with predictive maintenance systems that operate on an industrial Internet of Things backbone. Conveyor lines span hundreds of meters in fully enclosed, climate-controlled tunnels that feed directly into assembly hangars lined with fleets of synchronized robotic arms. And perhaps most astonishing to observers in the West, this isn't even BYD's only mega factory. China is executing multiple projects of this magnitude simultaneously across the country, while the US still struggles to break ground on its few planned gigafactories. The Zhengzhou facility is simply the most visible tip of a much larger, strategically coordinated manufacturing overhaul that positions China not just as a global EV powerhouse, but as the uncontested epicenter of industrial engineering. When the BYD megafactory in Zhengzhou opens its doors in 2026, it won't just be building cars, it will be manufacturing the future. And it will do so with a speed, precision, and scale that has left American engineers and policymakers stunned. While the US reflects on its fading industrial might, China is redefining what a manufacturing hub can be, executing in years what would take America decades, if it ever happened at all. From a distance, the Chongqing International Trade and Commerce Center looks like another skyline-defining tower in a city already overflowing with vertical ambition. But what's rising in Chongqing right now is not just a skyscraper. It's a bold architectural and engineering statement that leaves the United States grasping for comparison. Scheduled for completion in 2027, this super tall project isn't just tall, it's intensely complex, highly integrated, and deeply symbolic of China's new era of urban dominance. For US observers, it's another stark reminder of the growing gulf in technical capacity and mega project delivery. The tower is designed to push well past 500 meters in height, making it one of the tallest structures in Western China. Yet it's the location and engineering conditions that make this project truly extraordinary. Built in one of the most topographically challenging urban environments on Earth, the structure must anchor itself into hilly terrain riddled with ancient rock layers, underground water channels, and seismic vulnerabilities. The core structure is being stabilized using an interlocking tripod foundation, essentially 3 massive reinforced concrete legs that descend deep into bedrock and distribute loads across varying geological strata. This level of engineering finesse, executed in such tight urban quarters, would be nearly impossible to approve or coordinate in any major US city. The United States, once the pioneer of vertical construction, now lags far behind in realizing anything this sophisticated. While America still debates the merits of transit-oriented development and smart cities, Chongqing is actively embedding multi-use superstructures into the heart of its downtown. The Trade and Commerce Center will integrate luxury residences, commercial office spaces, high-end retail, and a world-class observation deck, all woven together with intelligent infrastructure and high-speed vertical transport systems. Elevators in this building will reach speeds exceeding 10 meters per second, operating with dynamic AI-assisted routing that reduces congestion and balances loads in real time. There is no equivalent system functioning at this scale in the US. In terms of construction methodology, Chinese crews are using a hybrid steel-concrete core that's pre-assembled off-site and lifted into place using climbing cranes that ascend the structure as it grows. Every element is meticulously pre-engineered with millimeter tolerances, and components are delivered just in time via dedicated supply corridors supported by smart logistics hubs. Compare this to the US, where even mid-rise towers in major cities often suffer from months-long delays due to material backlogs or labor shortages. China isn't improvising. China is executing with a military-like discipline and an engineering precision that the American construction industry hasn't mustered since the 1960s. Once the Chongqing International Trade and Commerce Center reaches full operational status in 2027, it will serve not just as a commercial anchor, but as a vertical city unto itself. A tower that absorbs the pressure of urban density, solves logistical challenges vertically, and embodies the sheer willpower of a country intent on mastering its terrain. In contrast, the US continues to repurpose office towers from the Cold War era and debate whether it can modernize without tearing itself apart politically. Meanwhile, China is quietly rewriting the playbook and building monuments like this one, while the rest of the world watches, stunned and left behind. It's not every day that an entire city rises from scratch, built not around sprawl and car dependency, but around integrated infrastructure, ecological balance, and digital governance from the ground up. Yet that's exactly what is happening in Hebei province with the creation of the Xiong'an New Area, a project so ambitious in scope and speed that it has stunned urban planners and civil engineers in the United States. Slated for full-phase completion by the early 2030s, with major infrastructural milestones arriving before 2030, Xiong'an isn't just a city, it's a systems-level reimagining of urbanism on a scale the US hasn't attempted since the founding of Washington, D.C., and even that pales in comparison. The planning phase alone set off alarm bells in American think tanks. China is building a technologically integrated city across hundreds of square kilometers of former farmland and wetlands, designed to absorb administrative functions from Beijing, support over 2 million residents, and operate entirely on smart infrastructure platforms from day one. The US, by contrast, can barely streamline broadband access in its own capital, let alone build a futuristic urban environment with climate-adaptive architecture, autonomous public transport networks, and digitized municipal services hardwired into its very foundations. What makes Xiong'an particularly shocking to US observers is how China is using the full weight of national coordination to push the project forward. Every utility trench, bridge, subway tunnel, and energy grid segment is part of a central master plan managed by vertically integrated design and construction units. In America, such coordination between federal, state, and local agencies remains elusive, and city-scale projects often die under the weight of conflicting jurisdictions. In China, earthworks, underground infrastructure, smart grid deployment, and data center integration all unfold simultaneously under one mandate. Construction in Xiong'an follows a bottom-up sequencing model rarely executed at this scale. The entire underground city, a two-level subterranean corridor system housing freight traffic, utilities, and service access, was prioritized before any superstructure went up. This allowed surface-level urban life to be planned around green corridors, pedestrian movement, and above-ground public transit, rather than being retrofitted awkwardly after the fact, as is typical in the US. American cities still wrestle with rerouting sewer lines built a century ago. In Xiong'an, fiber optics, stormwater management, and autonomous delivery routes are embedded before the first office tower breaks ground. Perhaps most humiliating to American infrastructure observers is the speed. What takes US cities a decade just to zone and review, Xiong'an has already begun implementing. Schools, hospitals, data hubs, and transportation hubs are operational or near completion before many Americans even learned the city existed. By the time Xiong'an reaches its operational zenith in the next several years, it will not only house over 1 million people, it will do so with climate-neutral energy systems, urban cooling zones, AI-regulated traffic patterns, and full-spectrum digital administration. This is not a utopia drawn on paper. It is a massive engineering reality unfolding with methodical precision, and it serves as a direct challenge to the United States, where aging infrastructure and decentralized governance make such projects nearly unthinkable. While America reflects on what it used to build, China is constructing the future, and cities like Xiong'an prove that they're doing it at a scale and sophistication the US has yet to match. No one in the American transportation sector expected China to push a high-speed rail corridor straight through some of the world's most hostile, geologically volatile terrain. Yet that is exactly what's happening with the Sichuan-Tibet Railway, specifically its most extreme segment between Ya'an and Ningqi. Scheduled for completion later this decade, this railway isn't just a new line. It's a geopolitical and engineering thunderclap that has left US infrastructure planners completely dumbfounded. While the US continues to struggle over basic high-speed rail concepts in California or the Northeast Corridor, China is carving precision tracks through mountains that American engineers wouldn't even consider penetrable. This section of the Sichuan-Tibet Railway traverses the eastern edge of the Qinghai-Tibet Plateau through a landscape racked by seismic activity, landslides, flash floods, and vertical elevation changes that defy conventional construction logic. From an engineering perspective, it is nothing short of madness. And yet, China is doing it. Over 90% of the route involves bridges or tunnels. The mountains are so steep and the river valleys so narrow that entire segments of track float in space, supported by towering piers driven into fractured bedrock, stabilized with custom-formulated grout mixtures and seismic dampers that adjust in real time. Meanwhile, in the United States, environmental assessments for even modest new lines can stretch across 2 decades. Lawsuits, land acquisition disputes, and lack of central authority all conspire to kill projects before they begin. In China, by contrast, the Ya'an-Ningqi section is being built in synchronized stages with satellite-monitored precision. Tunnel boring machines were airlifted into valleys by heavy-lift helicopters. Entire work camps were constructed at altitude with oxygen-enriched living quarters. Surveying drones and AI-assisted topographic models are guiding every borehole and anchor point. The rail line itself will be a marvel of operational engineering. Designed for high-speed service despite the rugged terrain, the railway includes multiple pressure-sealed passenger compartments to prevent altitude sickness, intelligent rail control systems with predictive braking logic, and anti-icing rail heaters embedded along the route, all while navigating zones with temperature swings of over 30 degrees Celsius in a single day. Nothing even remotely like this exists in the United States, where high-speed rail has remained a political fantasy rather than a technological commitment. One of the crown jewels of this section will be a series of deep-bore tunnels that punch through active fault zones at high elevation. These are not ordinary tunnels. They are lined with adaptive reinforcement systems that can flex and redistribute load during seismic events. In the US, existing tunnels on the East Coast still lack basic fire suppression or modern ventilation systems. The technological gap is growing by the year. Once the Ya'an-Ningqi segment of the Sichuan-Tibet Railway is fully operational, it will tie together regions previously considered logistically inaccessible. The United States, with all its legacy in railroad innovation, has nothing in its pipeline even approaching this level of difficulty or ambition. While American trains still crawl along Civil War-era routes, China is building what can only be described as a continental spinal cord. One tunnel, one bridge, one impossible kilometer at a time. Even in a country saturated with super tall structures, Golden Finance 117 in Tianjin stands apart, not just for its sheer height, but for the boldness of its design and the unapologetic ambition behind it. When completed in 2026, this towering vertical prism will soar over 590 meters into the sky, instantly ranking among the tallest buildings on Earth. For observers in the United States, the project is a striking reminder of just how far China has surged ahead in skyscraper engineering, while America clings to an aging skyline that hasn't fundamentally evolved since the 20th century. Unlike most Western skyscrapers, which are confined by historical districts, union constraints, or antiquated fire codes, Golden Finance 117 represents a new era of structural experimentation and engineering agility. The tapering diamond-shaped profile, for example, is not just a visual statement, it is a carefully calculated aerodynamic solution to reduce wind shear and vortex shedding, both of which pose critical challenges at this height. American cities, meanwhile, are still refining glass cladding systems and worrying about pigeons nesting in HVAC grills. The contrast is impossible to ignore. Structurally, the tower's reinforced concrete core is surrounded by a dense exoskeleton of diagonal steel braces and mega columns, forming a hybrid system that maximizes lateral stiffness and load distribution while preserving open floor plates for high-end commercial tenants. In seismic zones like Tianjin, this kind of approach is non-negotiable. But what's remarkable is the degree of vertical integration in the construction supply chain. Chinese crews fabricated much of the steel locally, shipped it in custom configurations to reduce on-site welding, and used GPS-guided cranes to slot sections together like a vertical jigsaw puzzle. Compare that to the US, where even mid-rise buildings are delayed due to international steel shortages or port delays. Elevator systems inside Golden Finance 117 will redefine vertical mobility. Double-deck high-speed elevators are engineered to travel at speeds exceeding 10 meters per second and utilize regenerative braking systems that feed power back into the grid. Another feature rarely seen in American buildings, where even modest modernization of elevator banks can take years to approve and fund. Integrated smart building controls will manage climate, lighting, security, and occupancy levels with millisecond responsiveness, creating an environment that is as efficient as it is opulent. While the US focuses on LEED certifications and carbon offset promises, China is simply embedding sustainability into the DNA of its structures. Golden Finance 117 will feature grey water recycling systems, insulated facade assemblies, and AI-managed HVAC zoning, all executed not as future upgrades, but as baseline specifications. It's a level of foresight and technical implementation that American developers can only dream about, hamstrung by fragmented contractors, risk-averse financiers, and rigid municipal building codes. By the time Golden Finance 117 opens its doors in 2026, it will stand not just as a monument of Chinese engineering, but as a literal skyline verdict on the state of American decline in the megastructure realm. While the US continues to rezone parking lots and debate high-rise shadows, China is rewriting the vertical blueprint, building higher, faster, smarter, and most of all, without hesitation.